In order to calculate a sea-level confidence interval for the unknown mean of a population, your data must apply to the following three conditions.
1. SRS. Our data are simple random sample of size n from the population of interest or come from a randomized experiment. 2. Normality. To assume a normal distribution, a sketch of the given data may be necessary. It is enough that the distribution be symmetric and single-peaked to be considered normal. 3. Independence. The population size must be at least 10 times the sample size.
Because standard deviation is not known, we must take the standard error of the statistic into account. The standard error of the sample mean is standard deviation over the radical n.
When standard deviation is not known, we must use the t-distribution. In a t-distribution, we specify each particular one by its degrees of freedom. We solve for df using the equation df equals n minus 1. Data may be given without average x, or s of x, in which case we must solve for the missing variables. We can use this by using a graphing calculator. When finding the confidence interval with an unknown standard deviation, we use t-star in the formula below.
Let's take a look at the example below. A new process for producing synthetic gems yields an SRS weighing 0.43, 0.52, 0.46, 0.60, and 0.56 carats respectively. Find a 90% confidence interval estimate for the mean carat weight from this process. Assume normal population.
First, list the conditions. 1. SRS is given. 2. Normality. Assume normal population. 3. Independence. N is greater than or equal to 10n, so we can assume that there is a large population of newly produced synthetic gems.
Next, plug the given data into the L1 list on the graphing calculator under Stat Edit. Under Stat Calc 1 var Stat L1, a list of data will be computed for use in this problem. We get the following information that's shown in the next two slides.
T star equals inverse T alpha degree of freedom, so it equals inverse T 0.055, which equals 2.015.
Now we can solve for the confidence interval using the formula shown below. This gives us a range of 0.49344 to 0.52645.
We can conclude that 90% of synthetic gems in the population weigh between 0.4934 and 0.5265 carats.